In our previous video, we were talking about different types of marketing analytics, and we were talking about product positioning. Which items should be cross-promoted with other items? And one of the methods for doing this is called an association rule analysis. It's also called affinity analysis or market basket analysis. So let's take a look at how this works. In theory. Come on. All right, so association rule analysis creates an association rule. An association rule has two parts. If something, then something. So the if part is the antecedent, and then the part that comes after the then is the consequent. So if someone buys shampoo, buying shampoo is the antecedent, then they will also buy conditioner. So conditioner is the consequent. So let's look at an example. Let's suppose there are 10 transactions. In those 10 transactions, 5 people buy shampoo and conditioner. So we think we can make a rule that says if people buy shampoo, then they will also buy conditioner. The benefit of having this association rule is that you could then predict the sales of conditioner based on what you see happening with shampoo. So if someone is picking up some shampoo off the shelf, and then they're likely to buy conditioner as well. So we would promote shampoo and conditioner together. We'd make it very clear, put them next to each other on the shelf, because we know that if they're looking for one, they're looking for the other. Okay, so we want to be able to create these association rules. We think that if someone buys shampoo, that's the antecedent, then they will also buy conditioner, the consequent. Now, we want to make sure that we have good rules that are helpful in making decisions for our organization, like placing the shampoo and conditioner together, forecasting what the sales and revenue are going to be, because we know if they buy one, they buy the other. So we need to look at, in 10 transactions, 5 people bought shampoo and conditioner. But in those 10 times, there were also 3 times where people bought shampoo and then they bought other stuff, not conditioner. And there were 2 times when people bought conditioner and they bought other stuff, but they didn't buy any shampoo. So we want to look at creating this association rule. When you look at your association rule, we look at the level of support for the rule. To find support, we look at the number of transactions that included both the antecedent, buy the shampoo, and the consequent, bought the conditioner, divided by the total number of transactions. So in this case, there were 5 times out of 10 when people bought both shampoo and conditioner. When you look at creating an association rule, you want the support to be close to 1 rather than 0. In this case, we're only at 50%. A higher level of support is a better rule. It's more helpful for the organization. Now we also look at confidence. So confidence is the number of transactions that include both the antecedent and the consequent. So 5 out of the 10 times people bought both shampoo and conditioner. And we're going to compare that to how many transactions included just how many transactions included the antecedent. So bought shampoo. In our scenario, right, we had 10 transactions, 5 people bought shampoo and conditioner, and then we had 3 times where people bought shampoo and they bought other things but no conditioner. So for our confidence calculation, we have 5 transactions with both shampoo and conditioner, and then we have 5 plus the 3 that include the antecedent. So those are the times they bought shampoo. So 5 divided by 8, we get 62.5%. When it comes to the confidence that we have in our rule, we want it to be closer to 1 rather than 0. So we're looking at the relationship between the events. A higher number is better because if you really want to be able to say if they buy shampoo, then they're going to buy conditioner, you can't have a lot of times where they bought shampoo but didn't buy the conditioner. Otherwise, your rule is not going to be that helpful. So we're looking for a higher level of confidence and a higher level of support. That is, we want a lot of the times where they buy both of those 2 things together, that's support. And we don't want a whole lot of times where they buy just the shampoo and not the conditioner. So we want a higher level of confidence as well. Now, when we come to analyze our association rule, we use what is called, that should say lift ratio, not life ratio. Lift ratio. So we want a higher lift ratio. The lift ratio comes from our confidence divided by the expected confidence. So we already talked about confidence, right? That was, we want them to buy shampoo and conditioner together compared to the amount of times they just bought shampoo. So not a lot of people just buying the antecedent. We want antecedent and consequent together so that we can say if they buy shampoo, then they buy conditioner. Well, expected confidence is the number of transactions including the consequent, so here buying conditioner, divided by the total number of transactions. Okay, so if we look at, go back to our 10 transactions, we had 5 times where people bought shampoo and conditioner, and 2 times when people bought conditioner, bought some other stuff, but didn't buy shampoo. So out of the total 10 transactions, 7 out of the 10 bought conditioner. Okay, so that's our expected confidence. 5 plus 2 divided by 10, 70% bought conditioner. Now, a lift ratio is going to be confidence divided by expected confidence. So in this particular example, our level of confidence was 62.5. We divide that by our 70%, and our lift ratio is 89.3%. Your goal with a lift ratio is to get a number that's more than 1. So the whole point of this is to be able to determine, better than random chance, whether someone is going to buy conditioner, the consequent. And so what we want to do is we want to be able to say, oh, that person who just picked up that shampoo, they're going to buy conditioner as well. So the goal is to have a lift ratio more than 1, which means that you are able to determine that someone is going to do the consequent, the conditioner here, with a better than random chance. If your lift ratio is 1.2, then buying the shampoo would increase the ability to identify someone who will purchase conditioner. We've enhanced that ability by 20%, right? 1 plus the 20%. If our lift ratio is 2, then they are 2 times more likely to buy conditioner if they bought shampoo. So we're trying to be able to predict who's going to buy the conditioner by the fact that they picked up the shampoo. So how do you do this in Python? All right, so if we go into Python, so what you're going to do is you're going to go to drstephpowers.github.io/BIA. We are here under Chapter 9 in Predictive Analytics because we're trying to determine what's going to happen. And we're right here in the one called Marketing. So go into Marketing, open in Google Colab. Remember, just like all the other ones, you need to make sure you are logged into your Google Drive. Make sure you save a copy to your drive so that you can play with and change up this code. Now, in this particular case, our code's pretty short and sweet. We're going to use a package called a priori. And so we need to do pip install, and we're just going to run that. It's not already built in, so we can't just do an import. We have to first install it. Okay. And then once that is installed, then we can import the a priori. Next thing we're going to need is a data set. So let's suppose we have a handful of transactions that are essentially the basket that someone has purchased. And so we talked in our previous video about how this association rule analysis is often called market basket analysis. And the reason is because we are looking at that basket. Oh, let's open the right one here. Which one was I running? This one, I guess. So we want to take those market baskets. So let's suppose that one person bought shampoo, hairspray, and eyeshadow. Next person bought shampoo and conditioner. Next person toothpaste, hairspray, and lipstick. Next person shampoo, conditioner, toothpaste. Next person eyeshadow, conditioner, lipstick. Okay. So we need our sets of transactions. Then what we're going to do is we're going to use this package that we just installed to find our lift ratios and our association rules. So when you do this, you are going to have it look at your transactions. You need to specify what is the minimum level of support, the minimum level of confidence, the minimum lift, and then you can also specify if you want the maximum length. And we're going to apply this a priori algorithm and have it list out its analysis. So that's what this is, and it kind of dumps out this information. Looks a bit like a mess. So let's break this down into what this means. All right, so we told it our transactions, and in this particular example, it just have 5 different transactions. When you are putting together your algorithm, you need to specify a minimum level of support. So you'll recall just a moment ago, we talked about how support was the number of transactions that include both the antecedent and consequent, here shampoo and conditioner, divided by the total number of transactions. So what's the minimum percentage that you will allow for it to create a rule for you? Now, in the example that I have here of these 5 scenarios, if I set the minimum support at 20%, then it will create a rule or policy if it just appears once in these transactions. So for example, you see shampoo and conditioner actually appear twice in 2 out of the 5. Shampoo and hairspray appear once. So it'll create a rule. If I put the minimum support at 0.2, it'll create a rule if it appears 1 out of those 5 times. So it'll create a rule for shampoo and hairspray. So likely you want to have a minimum support that's more than 20% if you only have 5 different transactions, because everything that's in your transactions will become a rule, right? So maybe you want it to be a bit more frequent. So I could put it at 40%, for example. It would have to appear 2 out of the 5 times in my transactions before it became a rule. Now, the other thing you're going to specify is the minimum confidence. So remember that when it comes to both support and confidence, we want closer to 1 rather than 0. And when it comes to confidence, we're looking at the relationship between the events. So we talked about in our example that the confidence is the number of times they bought the shampoo and conditioner divided by the number of times they just bought shampoo. So a lower confidence means there's a bunch of times they bought shampoo without buying the conditioner. We want there, if we're going to create a rule and use this to determine and forecast behavior and determine decisions for our organization, we want that confidence level to be higher. So we're probably going to put a minimum confidence, say around 80%. And then that's the minimum, and then it'll include rules for anything that has a higher level of confidence. Okay. And then our minimum lift should always be 1. Remember, when we talk about that lift ratio, we are talking about confidence divided by expected confidence. A lift ratio of 1.2 meant that buying shampoo increased the ability to identify that someone was going to purchase conditioner by 20% more than just random chance. A lift ratio of 2.5 meant that someone who bought shampoo was 2.5 times more likely to buy conditioner. So we're trying to be able to flag who's going to buy conditioner based on what they're doing with the shampoo. Okay? You want it more than 1. Otherwise, it's not really helping you at all in terms of determining whether or not they're going to buy the conditioner. In the example we went through, the lift ratio we had was lower than 1, and that's because there was only a 50% chance that they bought shampoo and conditioner, and so it didn't really help you identify whether they're going to buy conditioner, because there was all these other people who bought shampoo and no conditioner, and all these people who bought conditioner and no shampoo. And so it didn't really add to our predictive ability. Our lift ratio was less than 1. So we're looking for lift ratios more than 1. Now in the code I just showed you, when we ran this, we got this output right here. And so let's break this down a little bit more in terms of what this means. So let's go, if we can, here a little bit more detail. Maybe it's kind of hard to read. So it says relation record, and then it creates this frozen set here that's lipstick, conditioner, eyeshadow. Okay, it has a support of 0.2. And here what it's doing is it's saying, okay, from there, it's going to create this set that is conditioner and eyeshadow. And then that's going to predict lipstick. It's going to have a confidence of 1 and a lift of 2.5. So if someone purchases conditioner and eyeshadow, then the probability they also purchase lipstick is 2.5 times that of a random customer purchasing lipstick. So we have a lift of 2.5. There's a confidence of 1 here because there was no one who purchased conditioner and eyeshadow without also purchasing lipstick, right? We had one person who purchased lipstick or eyeshadow and conditioner. They also purchased lipstick. That confidence would be lower if there was someone who purchased conditioner and eyeshadow and then didn't get lipstick, right? If someone purchased conditioner and toothpaste, so we're going and looking at the next one here. I gotta find where's the conditioner and toothpaste. I just pulled a couple of these. Conditioner. That's shampoo. So if we just look at these, we have lipstick, conditioner, and eyeshadow. Sorry, conditioner and eyeshadow predicted lipstick. Lipstick and conditioner predicted eyeshadow. Lipstick and eyeshadow predicted conditioner. So you can see how it's taking different combinations that were in that first purchase. Then we have shampoo, conditioner, and toothpaste. And from there, conditioner and toothpaste predict shampoo. That has a lift of 1.67. Shampoo and toothpaste predicting conditioner has a lift of 1.67. Hairspray, shampoo, and eyeshadow. We can break that down into hairspray and eyeshadow predict shampoo with a lift of 1.67. Here we have shampoo and eyeshadow predict hairspray with a lift of 2.5. So here, shampoo and eyeshadow predict hairspray. And that's if they buy shampoo and eyeshadow, they're 2.5 times more likely to buy hairspray than just an average person, random person buying hairspray. Hairspray and shampoo predict eyeshadow with a lift of 2.5. Okay. So we're creating these rules that predict what is someone else is likely to purchase. So a summary here, if someone purchases conditioner and toothpaste, then probably they'll also purchase shampoo is 67% more than a random person. We have a lift of 1.67. If someone purchases hairspray and eyeshadow, then the probability they also purchase shampoo is 67% more than the random customer. So notice the lift of 1.67 is a 67% greater chance. If someone purchases hairspray and lipstick, then the probability they also purchase toothpaste is 2.5 times, a lift of 2.5. So you can see how you interpret the lift ratio. So higher lift ratios, increased chance of making that purchase of that particular good beyond just random chance. Now notice all of this output here. It's all these different scenarios. It can be purchase 2 things and then predict the third, purchase 3 things, predict a fourth, purchase 1 thing, predict a second. So when you do this association rule analysis, it's looking at all the different combinations. And in this particular example, you can see here all these different scenarios. See all the different lift ratios? That's all these different scenarios. That was simply from 5 purchases, 5 transactions. Now, we had a low support. We put the support at 0.2, so there's more of them. If we reduce the number of, if we increase the support from 0.2, that's not the one I was running. So we raise that up. Notice there's none here, and that's because we don't have any repeats really in this scenario here. So that's going to impact the number of rules that you have. And so moving it up, you would move it up because we want more robust rules, things that where there is not just one person, but many people who do it. But you would need, of course, a bigger sample here than just these 5 scenarios. The only challenge with this method is that this method, it doesn't work well for really big data sets. It works well for relatively small. So if you only have 10, 20 transactions, you're fine. But if you're looking at 10,000 transactions, hundreds of thousands of transactions, you don't want to use this particular method because it is so cumbersome in terms of all the different combinations and computationally taxing. So if you do have a much larger data set, then the approach that you want to take is not the association rule analysis, but instead you want to use content-based filtering, recommendation algorithms, which we'll go through in a different video.